Good afternoon and good morning. Welcome to today's Second Nature webinar. My name's Eric Howard, and I'm the Director of Strategic Partnerships here at Second Nature. For today's webinar, we have 45 different campuses represented on the registration list, plus 24 businesses and service providers, as well as professional staff from some government agencies. We cover the four corners from Maine down to Gainesville, Florida, British Columbia down to San Diego. Our most distant person is actually based in Auckland, New Zealand, where it's the middle of the night, and they signed up through the hearing about it on LinkedIn. We very much appreciate your interest in participating in today's peer-to-peer learning program. There have been very many interesting developments in recent months, and a lot of campus leaders are looking at ways to fulfill their commitments to building a low carbon economy. Things like what they can do to, and the important questions are how we can support and jumpstart a journey toward zero carbon. One solution is improved infrastructure, and there are many questions that need to be addressed with respect to infrastructure, such as the technology, all the way up to when do you talk to the president or the board of trustees or the chief financial officer. We'll be talking about some of these things today, and the lessons from today's program hopefully will be relevant to smaller institutions as well as larger ones, public as well as private. During today's webinar, you'll be hearing about the experience of peers at Eastern Washington University, which is in Spokane and Cheney, as well as from McKinstry, which is a national firm based in Seattle. Quick outline for today. Again, this is Eric Howard. I'm giving a brief introduction. Then you'll be hearing from both Brad and David. We have some questions already that have been submitted, and the last 20 minutes will be question and answer. There's a place in the control panel for you to submit questions to us, and we'll try to get through many of those. You'll also have an opportunity to follow up with any of us in the future. The very last slide in the program is the contact details for us. Before I hand over the microphone, I do want to give a quick thank you to the many universities and nonprofits and corporate partners that we work with us, including today's sponsor, McKinstry. I also want to acknowledge some of our other sponsors in alphabetical order. They include Customer First Renewables, NG, McKinstry, Metris Energy, Open Road Renewables, and Siemens. If you want to see a full list of our sponsors and nonprofit partners, you can go to our website, which is secondnature.org. And so now I turn it over and look forward to hearing what everyone has to say.
Thanks, Eric. This is David Bowman. I'm the Dean of the College of STEM at Eastern Washington University. I will kick off our webinar by giving a little introduction to Eastern and to the Catalyst project and the importance to the university, and then turn over to Brad to talk about a lot of the important technical aspects of the project, and I will also then step in again to talk about how the challenge of being in a zero energy building has really allowed us to look closely at what we do and our processes and adapt both ourselves and our curriculum to meet this great opportunity to be in such a revolutionary building. So Eric, if I could have the next slide. Eastern Washington University is a regional comprehensive public university. We have about 12,000 students with more than 100 majors in 5 different colleges. Our main campus is in Cheney, Washington, which is a small town about 15-20 miles outside of Spokane, with another campus in downtown Spokane that we share with Washington State University and in collaboration with Gonzaga University, Whitman University, and University of Washington. That's a signature part of the city of Spokane to have this university district where we all collaborate together. And the Catalyst building is a great opportunity for us to increase our presence, in particular of our engineering programs in downtown Spokane. So Eric, if you can give me the next slide. Cheney is a rural community where our main campus is. So to give you some regional context, and the lower right-hand slide there, you see the state of Washington. Eastern Washington University is in the eastern part of the state. When I moved here 3 years ago, everybody asked me if I liked the rain. That's Seattle. We're on the dry side of the state. We have a lot more climate extreme than you get in Seattle, and that's one of the interesting challenges in having a zero energy building, is that we run from very hot summers to very cold, snowy winters, and that's, you know, given Brad and his crew some fun in the design aspects. Eastern is in Cheney, as I mentioned, about 20 miles outside of Spokane. And another one of the things that I learned when I came to Spokane, I was very interested in building partnerships with industry in Spokane, which is a large city. It's about 500,000 people in the metropolitan area. It's the second biggest city in the state of Washington, and it does have a fairly developed tech and industry base. And when I came to Eastern, I was very interested in building those partnerships with engineering and tech firms in the city. And the chair of the engineering department told me something I'll never forget. He said, "Dave, you have to understand that Cheney is only 20 miles from, Spokane is only 20 miles from Cheney, but Cheney is 80 miles from Spokane." And in some ways that's true. We are quite distant out of the city center in terms of partnerships with industry. And one of the exciting things about the Catalyst building for us is that it will be in downtown Spokane. So Eric, if we can have the next slide. This will show you a little bit of our Cheney campus. It's a beautiful campus, but we are right up in the trees at the interface between the forested areas and actually the Palouse Prairie. And the next slide will show that what we're doing is moving ourselves to the Catalyst building right in downtown Spokane. And I think that it's exciting for us because downtown Spokane is really where the heart of these industries that we serve are located. The College of STEM in the next slide is the largest college in our university. It's about 25% of all students. We cover all the STEM fields, the basic sciences, biology, chemistry, geology, math, and all of the applied sciences, computer science, and a spectrum of engineering degrees from electrical, mechanical, applied technology, manufacturing, construction, and visual communication design, which we'll hear more about later. And what we will be doing is, with this opportunity, is bringing some of our programs down to where that industry is located, as I mentioned. And part of the challenge for us in moving a STEM college to a zero energy building is that the STEM fields are notorious energy hogs. We use a lot of energy in what we do. Fume hoods are very energy intensive. The sorts of things you have in metal shops and wood shops are very energy intensive. So in making a move to a zero energy building, we had to be very intentional about the programs that we were moving to be able to accomplish this. And so we really focused our efforts on moving our electrical engineering, computer science, and visual communication design groups specifically into the downtown corridor. Eric, if I have the next slide. So the downtown area that we're moving to, the University District, as I mentioned, is joint between several of the regional universities. This is an aerial shot taken hovering above the Gonzaga University campus. It shows in yellow the portion of Spokane that is occupied by all of these universities in cooperation. The red arrow that you see points to EWU's main building on that campus, where we already have our College of Health Science and College of Business. This really helped facilitate our project in moving into the Catalyst building, into this great facility, because we already have student services and many of the other things that you need to support an educational program in place on the University District. And you can also see very nicely from this image that on the right-hand side of the image there is the core of downtown Spokane. So we're really bringing ourselves into the heart of the city, which is very exciting. Can I have the next slide? So this actually is a picture. The little telescope there in the center is showing where I'm standing, where I take this picture, looking towards the gray arrow of the Catalyst building. This is a picture from 2 days ago of the Catalyst building construction. It's really exciting. But I also want to share this because I think one of the interesting things about this development for the region, for the university, and for local industry is that the Catalyst building is the first step on what they're calling the South Landing. The aerial image there is actually looking to the south, and the university district where most of our activities have been focused is actually separated from the southern half of the town by a railroad track. And the Catalyst building is part of what's called the South Landing project. We are literally the bridge to the other side of the tracks there, where there's a huge growth in technology companies, which McKinstry and Avista have been leading together. And it is designed to be an eco zone where we will have very, very green industries going into place and supporting innovative new buildings like Catalyst. And the photo that you see on the inside on the lower right shows the footbridge that's been built across the railroad tracks that actually connects the existing university district to the new frontier on the South Landing with Catalyst. And Catalyst is the wood building that you see in the left center of the frame with the cranes around it. It's very exciting to see it go up. We drive by periodically just to see it growing. Eric, if you give me the next slide. So as I mentioned, this building is going up quite quickly. We take pictures as often as we can because it's amazing how fast construction moves on a building of this type. And I'm sure Brad will allude to that. So we are anticipating occupying the building in fall of 2020. And we'll be moving our EE, computer science, computer engineering, and visual communication design students there. And we're looking forward to being able to use all the things that Brad is about to tell you about.
Great. Thanks, Dean Bowman. I really appreciate it. So before I dive in, I just want to share a little bit about McKinstry. Folks may or may not be aware of us, and so I want to give you a little bit of context for who we are. McKinstry is I would say, mid to large size design, construction, and building operation company that's focused on buildings and the built environment. Our business lines are very wide ranging, but just to kind of summarize them briefly, we have kind of 4 main areas of focus. We do engineering and consulting work. We have about 85 engineers company-wide. The backbone of the company is construction. So we do construction from just a whole range of scales, all the way from the largest buildings you can think of, stadiums and hospitals and high rises, all the way down to small boiler replacements and retrofit work. We also have a very large part of our business that's very dedicated to energy efficiency. We do, if you think about the built environment, we can't build our way out of the climate crisis just with new construction. We have to really also be very focused on energy retrofits and working with the existing context, and that's been something that McKinstry has long recognized. So both efficiency side work as well as renewables. And then we also do service and maintenance work. Again, in terms of range, everything from very small to very, very large. Next slide. Geographically, we are located really in the western 2/3 of the U.S. So we do service all over the place in really, I would say we don't really do work on the eastern seaboard, but pretty much everywhere else. We have a couple thousand employees. We're privately held, which allows us to do quite a bit. We're kind of a nice size organization that way. Okay, to just get into the heart of things. I think probably a lot of the folks on the webinar are familiar with um, these facts, but probably some of you are not, and I think they're important. You know, if you think about the climate crisis and all the things that we're dealing with increasingly, you know, I think taking a quantitative analytic approach to how do we deal with this as a problem and resolve it, I think it's important to pull the lens back and really think big picture about, well, where are we using energy as a culture and society? And, you know, I think a lot of folks tend to focus on transportation. Many of us sit in traffic and cars and flying, et cetera. And that is a really important part of our climate footprint. Industry and agriculture is also, you know, how we make things is also very energy intensive. But kind of the benign backdrop of buildings operating is really the single largest energy use in the United States. It hovers around 40%, and it has for years and years. And so, if you think about it from a higher ed standpoint, that percentage is even, you know, much higher. Next slide. So I want to talk a little bit about zero energy. So I'm going to give kind of a background on zero energy, and then we'll dive into talking about Catalyst and how it's achieving zero energy. So the idea of zero energy is at its most simple, a fairly simple concept, and it's basically a building that uses as much power as it can generate over the course of a year. So I'll kind of say that again. So if you think about a building, we're not talking about an off-grid building. We're talking about a building that's connected to the energy grid. And it basically is both, it draws energy from the grid, but it also generates energy and puts it back on the grid. And that the amount of energy over the course of the year that it generates is equal to the amount that it uses. And that's what is called a net zero energy building. It's kind of amazing to think that we can even achieve that. And we'll unpack that a little bit over the course of the webinar. So if you look at this chart, energy production is in blue. So this is January through December. This is in Seattle. So if you think about how this is assuming a building with solar panels, for example, in northern climes, particularly in Seattle, and frankly, it's not, well, it is, I'll stay focused on Seattle here. So in Seattle, it's cloudy in the winter, and it is actually somewhat sunny in the summer sometimes. So we get decent solar generation in the summer. So we generate a zero energy building in Seattle will generate far more energy than it uses during the summer. In the winter time, we don't generate that much. If you look at the consumption side, what's interesting with a zero energy building is because, you know, in Seattle typically, or in most northern buildings, the buildings tend to use much more energy in the winter because they're heating dominated. And so, but with a zero energy building, those wings kind of drop down and they just use slightly more energy during the winter. If you could go to the next slide, Eric. The basic idea is that your surplus either is equal to or generates what your deficit is in terms of your grid relationship. Next slide. So I'm going to spend some time over the course of the webinar just talking about, well, what's good about this? I mean, I think to a certain degree it's really self-evident, but there's a lot of benefits to zero energy buildings that are maybe beyond what's immediately apparent. So one thing that is really great about zero energy buildings is to live within the means of what you can generate on site. You really have to get tremendously efficient. It's not just, we're not talking about just taking a normal building and putting solar panels on it. There's only a handful of buildings that could actually be net zero if you took that approach. To live within the means of that solar cap, you really have to just drop your energy use dramatically. And so about 3 years ago, I wrote and published a book, or it was published, called The Power of Zero. And what we did in that book is we looked at 20 case studies of actual energy performance and how zero energy buildings actually achieved zero. And so if you look at this graph on the left, the orange is say an average office building energy use. And then on the right is how all the zero energy buildings in that book performed. And you can see that the average is around a 70% improvement over the norm. So zero energy really drives efficiency, which is fantastic. Next slide. So, I also want to share just a bit on zero energy versus zero carbon. And I also want to share kind of a new generation of thinking around zero energy buildings. So one of the things that became clear to those of us in the zero energy movement 2 or 3 years ago was that we were actually, the sample size that we could deal with on what could actually achieve zero energy, even if you were extremely efficient, we were limiting ourselves to really the less dense and less intense building uses. So things like high rises, hospitals, labs, there was no way that those buildings, even if they were just tremendously efficient, could generate enough power to offset their energy use. And so a new pathway was created through the Living Future Institute, whereby, which is the certifying body for zero energy and zero carbon buildings, whereby there is an allowance to allow off-site renewables. And what that did is that really opened up the floodgates for these higher intensity and higher density uses. So there is, just to be clear with folks, if you have a highly intense building, a high intensity building like a hospital or lab, there is a pathway for you. And then with zero carbon, there is also a pathway that allows, zero carbon is very similar to zero energy. Some of the energy requirements are less stringent, but zero carbon buildings also look at the carbon embedded in the act of constructing the building. And that's really the differentiating feature of a zero carbon building. I'm going very quickly over this. I'm sure there's a lot of people saying, yes, but. So big picture, this is the energy, kind of the energy roadmap of how we get from a typical building to a zero energy building, and this is specific to Catalyst. So if you just take in some of these elements, you think about heating in a typical building. A typical building uses a boiler, doesn't have very good insulation, and so it uses a lot of energy to heat the building, and that's represented in the dark blue here. And note just how much less energy we're using in Catalyst for heating the building. It's just amazing. And so when next slide, we'll start talking about how we're actually doing that with Catalyst. Dean Bowman already talked about kind of the big picture of Catalyst and South Landing. Just to be clear, we're kind of talking about two projects in one. One is that, and just to share a little bit, the McKinstry ownership team really wanted to create a catalytic example of what we believe is possible in the built environment. And so they are developing with regional partners like Avista Utilities a high-tech campus that includes a zero energy building, and that's the Catalyst building. And so the Catalyst building is represented in the upper left corner, kind of that long linear 2-box gray building. And then there's also a district energy system. It's a quite innovative district system that is providing heating and cooling for this entire district. And so I'm going to talk about both those things. Next slide. So this is a cross-section of Catalyst, and one of the things that's quite innovative about the building is there's really a revolution going on right now in construction technology called cross-laminated timbers. It's very interesting. It's a return to wood construction, and if you look at the embodied carbon represented by either wood construction or steel and cement construction, it generates far, far more CO2 than wood buildings do. And so we are pioneering the use of CLT on this building. So it is going to be a wooden structure. I could talk at length about that. I won't, but it is, and we're starting to see in different places very high, tall buildings that are built of wood, and they've been able to address the fire concerns associated with it. Next slide. this image shows both kind of how the panel assembly comes together with cross-laminated timber. But the reason I actually wanted to show this was to talk about the insulation in the building. You know, our buildings in the past have been quite primitive about how we've frankly insulated them. We've basically taken the structure of the building, put insulation in the caps, and called it good. That's like, well, that's how much insulation we can fit in there. And the reality is that doesn't really get us to an optimal level of insulation in the building. You have to go further than that. And there's a lot of opportunity there. So we are providing about twice as much insulation at Catalyst as a typical building. And the way we're doing that is we're hanging a large amount of insulation on the outside of the building. In addition to that, we're also providing triple pane windows, which are highly energy efficient and again about twice as insulated as a typical window, with also excellent framing. Next slide. Another element that's quite interesting is buildings are probably far more leaky than most people recognize. You kind of would assume, you know, when a building is built that it would be, you know, there wouldn't be air gaps or seams or air leakage, but it's actually quite prevalent. You know, the average home exchanges air with the outside on average about every 4 or 5 hours. Commercial buildings are typically better than that, but they're still not great. And so one of the things that we'll be doing is air sealing the building to a very, very high performance level. Next slide. To a passive house standard for those of you who know that. I'm not going to do a real deep dive on this, but just to show you kind of the differences between the mechanical systems of a typical building versus the Catalyst building. You know, a typical building has a mechanical system that is a little bit, it's, you know, you have this massive mechanical system that is kind of does everything. It cools, it heats, and it ventilates, and it's all in one package. And so if you need to, let's just say a small part of the building needs heating or cooling or ventilation, you actually have to crank up that big thing that on many buildings is literally the size of a locomotive. And so to provide, you know, what might be just a very small bit of service in the building, you're using this huge machine to do it. It's very inefficient. Another thing that is not great about these older systems is when it's really cold, you tend to use dampers to shut off outside air, and you're just recirculating air internally, so you're not getting good fresh air in the building either. So with Catalyst and other high performance buildings, Eric's moving me along. Can you just go back really quick? We've separated the ventilation system from the heating and cooling system, which is, you know, it allows much greater efficiency and also allows us to use a heat exchanger to bring fresh air in that's pre-warmed by the exhaust air. Next slide. Daylighting is a very important component. Lighting is very important. So, you know, people like to be in daylit spaces, and it's an energy saving measure. So we're taking that very seriously at Catalyst. Next slide. And so I'm just going to wrap up and talk briefly about our district energy system. So as mentioned, Catalyst will be served by a multifaceted district system that actually uses 7 different heating and cooling components in it to make for a super efficient system. Next slide. Next slide's definitely my geekiest slide of the whole deck. So bear with me here, but what this is showing is over the course of 12 months, how those different components are contributing to heating and cooling in the building. And that's about all I'll say about it. But if you go to the next slide, if you take all those systems in aggregate, it's 4 times more efficient than a typical building heating and cooling system. We're able to capitalize on different efficiencies and use extremely efficient systems within that, which is, you know, just quite tremendous and is really helping us get to the zero energy. Another element or aspect of that really makes the district system compelling is that it allows us, by serving 5 buildings, we're able to do some things with the district system that you probably wouldn't do on a single building. We're able to do you could do some of them on an individual building, but probably not all. And then I think, I have a couple of slides, just next couple of slides. I'm sorry, we do have renewables on the roof, as well as off-site. So this building will use that off-site pathway I was talking about. Next slide. And then I just have a couple photos of construction. That is the Catalyst building. A couple weeks ago, not as recent as Dr. Bowman's photos. Next slide. This slide is of where the district energy system. It'll be down in the bottom there. So, and one thing I didn't talk about are plug-in user loads, and Dean Bowman is now going to talk about those.
Thanks, Brad. So it's a really exciting building, and it's very exciting to have electrical engineering in particular moving to this, because it's kind of a living laboratory for them in many real ways. It's something we need to think carefully about as we move into a zero energy building. How do we do this? I think the most critical element was really the choice of what we're going to do. Brad is absolutely correct. You can do very high intensity things in a zero energy building. But we wanted to be very careful and focus on that within the constraints that we have with the hub building and on designing that South Landing area. So we really focused on programs to move that did not have wet labs, did not have fume hoods. We didn't want to have shops that are very energy intensive and not necessarily always very efficient. And we really wanted to work on our curriculum itself to be able to be efficiently used within the building. We really needed to focus on minimizing our curriculum so that the things that we're teaching on the building really are focusing on what they need for those designated programs, and really using that opportunity to maximize how much work the students are doing with outside industry partners. So it's really revolutionary for us in how we're going to use our programs within this building. And I think that's one of the main messages for me. I know that many of you on the webinar are coming from the academic side of the house. It's really affording us a great opportunity to look at our own selves from a different view. So the next slide. We're also going to, using this as an opportunity to really focus on our teaching in particular within this context. Part of the great thing about a zero energy building, it really is telling us to think about ourselves in a different way than we have traditionally. And we're taking that quite seriously in our programs. We're looking at our curriculum to be in this and really trying to understand how the flow of students can be managed so that we can exist correctly and well in this zero energy space. So the impact on us curricularly is that we're really focusing on this building being where students are doing the courses in their major. Their allied science courses, specifically chemistry and physics, will still be done on the Cheney campus. In our not traditional science building, we're getting a new science building there as well, which is also far more energy efficient than has traditionally been the case. And we're also focusing on our general education being completed as much as possible elsewhere to be able to make sure that the materials that we're using in our curriculum are the most energy efficient possible within what the building needs are. That means we're doing a lot more reliance on online education than has traditionally been the case. It's a great thing. It's really helping us rethink and reimagine ourselves really from the top to the bottom. So from the details for those of you who are academics here on the next slide, we've really had to restructure our curriculum, and this is somewhat boring and a little fuzzy, but the lines on here on this spreadsheet, this is one of our working documents that shows how we're going to be managing the flow of students between our Cheney campus and the Catalyst building downtown. And the green lines on there are classes. that students will be taking initially in their freshman year, all on the Cheney campus. And if you can see that, it's mostly a lot of our physics and mechanics and the very lab intensive courses that will move through their sophomore year. And then you'll see that we're starting to have a little bit of courses happening both in Catalyst and in Cheney. That's because we're starting to have courses that are beamed back and forth. Now, this is something that some of your campuses may do, some may not. It's not truly online learning. What we will be doing is having specially equipped classrooms, both here in Cheney and in Catalyst, that have the ability for students to be in a traditional lecture situation while also capturing it all online and being telepresent in a classroom on the other campus. Because some of our courses, we don't want to have to teach 5 different sections of them. We want to teach, our electrical engineering circuits lecture class and be able to have the lecture for students who are still on the Cheney campus and on the Catalyst campus. And so they'll be telepresent through the wonders of the internet. Before finally, as juniors, they become fully Catalyst students working entirely on their hands-on portions of their curriculum. And what's exciting for us from a curricular perspective, beginning to work a lot more closely with industry partners who will be nearby and actually in the Catalyst building along with us. A few things from a curricular perspective, challenges if you're considering moving engineering programs into a situation like this. Engineering, unlike many degree programs, has to have the technical courses spread throughout the curriculum. You can't just say take your general education your first 2 years and your engineering classes the last 2 years. In order to keep the flow of the hierarchy of the major to go smoothly through all 4 years of a student's career, we have to have general education happening all through it. Now, that kind of works contrary to what our original goal was with concentrating our teaching and the resources we're putting in the building. And we're accomplishing that again through online, which is a great help in managing our energy usage. And it's wonderful too, because it also cuts down car trips, which is not captured in what Brad was talking about in terms of the zero energy. But I think that's going to be a side benefit that would be great to capture as well. By doing this, we're also reducing car trips back and forth between Cheney and Spokane. Eric, if I could have the next slide. One of the great things for us is that this has also made us focus on plug load, as Brad alluded to. Like most academic programs, we've never found a computer we couldn't find another use for. And there is always the tendency to keep your old computers and move it to a new lab, do a new thing. And the move to Catalyst has really made us look at that closely, because those old computers are energy hogs. They have a very high plug load. And a really nice benefit of moving downtown is that we've had to really look closely at upgrading all of the old computers and saying occasionally to a faculty member, I love that 386, it's time to let it go. And so it's really allowed us to modernize and update a lot of our facilities in our labs and in our faculty classrooms. And I think everybody's actually really liking the opportunity to get newer machines and to realize that it's okay to let that one go. So that's been a really big benefit. And it's a bit of a culture change that has to happen to make that work, but it's a really good thing. We're also moving away from labs like the one you see in the picture that are computer labs with computers and monitors on desks. In the modern world, everybody carries around a computer. They're everywhere. They're in your pocket. Okay, so the old idea of a computer lab is almost becoming out of date, and the students have them with them. And so many of our computer labs, we're just eliminating because they're not needed in the modern context. And that has also helped a lot with meeting the plug load that we want to accomplish in this building so that we can be net zero. If I can have the next slide. The biggest actual cultural change that we have to do isn't actually around our teaching in our labs. I joke about needing to get rid of the old computers, but that was actually pretty easy. Look, you get a brand new one. Oh, okay. The real challenge is in the culture of our office spaces, quite frankly. Brad showed the beautiful image of what the space will look like with this big open office concept. That's always the best thing for an energy management perspective. It helps you manage your heating load better. It helps you manage your daylighting and light. It's a challenge to do that in an academic context. And the reason is that with faculty in their offices, they want to have private conversations with students about their grades. And particularly for an institution like Eastern, where we have a huge number of first generation students, a huge number of non-traditional students that may have many working students that may have many things going on in their lives. Our faculty are often as much content experts as they are counselors. And we need to be able to have that place of trust continue with the faculty. And so privacy for the faculty was really very important. And that puts a challenge with the need to have a daylight driven lighting system. So if we get, so this is a ground floor plan for our main office portion of the building. And Eric, if you go to the next one, we'll zoom in a little bit. So it was very important to us that privacy in particular be maintained as paramount for the administrative offices, for the department chairs. They not only have student issues, but also personnel things that they deal with, budgetary issues. And so that portion that we see right here is the only portion of our space, our office space, that has traditional sealed offices with, when you look up at the ceiling, you see a roof. We've limited really just to those administrative spaces, which forced us to move them to the outer walls of the building so that they would have access to the daylight. It also, that had a big impact on how we structure where things are, and I think it's a good thing. If you go to the next slide, the office spaces for the faculty are not full height walls. And that has a lot of implications. If we go to the next slide, this is one of the things that McKinstry was very helpful at doing, is building some mock-ups of what these offices would look like to help the faculty understand how they'd be able to work with their students. So this is a picture from inside one of the mock-ups that McKinstry did of the office space, and you'll see the white are the walls. Clear doors are very important to allow as much light as possible to flow through into the interior corridors of the building, but you'll see that the wall only goes partway up. The sort of brown and studs is the warehouse that we're building these mock-up inside of. It's a wall that goes up higher than somebody can stand, and then it's open ceiling above that to facilitate airflow. It also helps light go through above the offices into the offices more towards the interior of the building. That was a really important design concept to meet the zero energy needs of the building. We had to build mock-ups because we needed to also gain trust from the shareholders, that they could sit in this office and have a very loud person like me in one office and not be impinging on or be able to be heard by people in the next offices. And McKinstry has some really neat high-tech ways that they're doing this using drop-down ceiling tiles. If I have the next slide. So because the sound insulation is not 100%, we've also provided new spaces for faculty to have confidential discussions. Eric, if I could have the next one. You will see, before I get to that, not all of our spaces need to have that same level of confidentiality that the tenure track faculty have with their students. We have a lot of adjunct faculty here, and it's something we hope to see increase by being downtown. So most of those faculty we have in cubicle farms. The walls, this is something we're working on right now. The walls are going to be a little bit higher than that to try to promote the privacy as much as possible, but this again really helps us focus on our energy usage. Next slide. And that's something that I'm sure many of your universities are already doing with adjunct faculty and graduate students. But because of that, we've put throughout the office areas of the building these small conference rooms. And that's a bit of a culture shift for us. And that is so that if a faculty member has office hours, that they know they're going to have a lot of people, they have a place that actually is sound insulated. These conference rooms actually have a hard cap ceiling to provide a sound proof area for confidential discussions or office hours, things like this. And that allows them to leave the area where you might have sound leakage into the next room and still be able to perform that function. That was a really important innovation, if you will, in terms of the design of the building to permit that happen so that we can maximize the energy usage. Next slide. So I think the key takeaway in the short time that we can on this that I want to emphasize is it's really that change is really important that we've done in trying to live within this concept of zero energy. It's really facilitated a lot of important discussions that are good across the curriculum, updating equipment, updating our curriculum, focusing our support services, and really modernizing all of our policies for space usage. So not only are we going to have a better building, but I really do believe that this is going to lead us to better programs that we're going to be offering to our students. And you can move to the next one, Eric.
That's great. Okay. We're running, just full disclosure, we're running a bit behind, and so I'm going to, Dave and I are passionate people, as you can tell. I'm going to go really quickly through these last slides, and actually either Dave or Eric, you have your mic on. If you could turn it off, that would be great. We're getting some feedback. There we go. Okay, I'm going to move quickly. If I move too quickly, and if somebody really wants to hear some of the details, our contact information is at the end, and please let me know, and I'm happy to connect with you and share some of the thinking. So just very quickly, I want to share some of the highlights of what are other benefits of zero energy buildings. One is that, believe it or not, they, at this time with the climate crisis where we unfortunately are so bifurcated around how to deal with this, zero energy is remarkably broad spectrum. People really respond to it. It's high tech, it's can do, and it's a climate solution. Next slide. And that is a really important thing. So the next three slides I want to show you are related to zero energy buildings are not, they actually are better buildings, to build off what Dave was just saying. We're not, but that's only a potential. You can have a zero energy building that's just sort of like, oh, it's as good as a normal building, maybe even worse. But if it's designed correctly, you can actually capitalize on the elements to make for a better building, and so you capture more value. So one is that they're just better buildings for the occupants. Views out, they're quieter, more thermally comfortable. Next slide. They're also potentially more durable buildings. And I've had a lot of people say, well, boy, aren't all these gee whiz technologies just actually, they're probably really finicky and they're going to break down and all that stuff. And I actually believe that the opposite is true. These are easier to operate buildings. And if they're done right, they're more durable. And particularly the shell of the building often is much, much better than a conventional construction. Next slide. So if you think about 250-year legacy buildings, zero energy and higher ed really fit together. Next slide. Yeah. And then another really great benefit is that, you think about, okay, in a time of crisis, let's say you have no power inputs to the building. If you design the building right, if you have good daylighting, if you have good insulation, that actually means that building might actually be quite occupiable in the event of no power, and it provides kind of the fundamental meaning of shelter. Next slide. I just want to talk briefly about campus level planning and zero energy. This is going to be really quick, but if you think about a campus doing a zero energy or zero carbon campus, the idea of like covering all the consumption and all the production and offsetting all of it, which many of the folks on the phone we have as a goal. It's conveniently a couple decades out, but we got to be thinking about it now. Next slide. So just to share some high-level thinking about this, we do a lot of campus planning, and I think it's really important that your zero energy planning can't stand alone. It needs to be incorporated into the rest of your planning. So if you're really going to get legs with your facilities group, your construction group, your capital group, think very big picture about it and take into account everything and how you're doing it. Next, if you could just do the next 2 slides, actually. Just, yeah, go to the next slide. This is some facilities assessment work that we do where we look at a whole range of things, not just, site EUI that's listed there is the energy efficiency part of it, but there's all these other elements that you can take into account when making decisions about your capital facilities and what to hit next. Next slide. This is just another example this is actually a hospital where we're looking at things floor by floor and literally room by room. Next slide. And just also just at a high level to think through, with higher ed, again, you're not going to rebuild the whole campus. To get to zero energy campus wide, you have to take a very strategic, thoughtful approach in how you're dealing with all of the buildings and how far can you go and what makes sense to do on different buildings. So if you think about it in terms of, well, how far can you push buildings? Some buildings you can take kind of a light approach. Next slide. Some buildings you can take a deeper approach where you're getting really aggressive. You might be actually getting into the envelope of the building, but you could get really high results through that. And then finally, in some situations, you might just use the shell of the building, but gut the whole building, use the core of it, and then really start over and almost treat it as new construction. Next slide. This is just something to stimulate some thinking, but, a lot of time folks will say, well, how much does zero energy cost? And, and I think people really can approach this far too primitive of a way. The capital costs can be more, not necessarily. You can have trade-offs with other things and just say, we're going to prioritize this. But just to simplify things, I want to emphasize, the benefit of no utility bills accruing over 20 or 30 years is really substantial. And it will always, I guarantee you, will offset the increased capital cost if you're doing it thoughtfully and you're making sure you're capturing all that utility cost benefit. Next slide. And then I think this is particularly important is, we're dealing with a dynamic situation often in fundraising around new capital facilities in particular. And if you go further, often you can benefit the building by essentially, if you say, hey, this is a zero energy building, it's going to be the first in the state or what have you, it can actually be a way to actually get great fundraising and actually reduce the amount of indebtedness you need to receive. And so, there's a college that I was working with on the East Coast that, we had the design charrettes and they were like, okay, now we're going to go fundraise. And I thought, okay, well, we'll talk to them in a year or two. And they called us back in a month because they found a single donor that was like, this is so cool. We're going to pay for the whole thing. And so that is a very real phenomenon that I think it's worth paying attention to. Last slide. I just want to challenge everybody. I think one thing that I think is really important on campuses is you may not be able to have every building be as stellar as what we're doing on Catalyst, but you could have one or a small handful of them of new construction. Use that building to be a catalyst for reconfiguring your whole approach along the lines of what Dean Bowman was talking about. Thanks. And we'll jump into questions.
Okay, thank you very much. I am realizing that we're getting close to the end of the hour. Before I start with the questions, I just want to say thanks to all who have participated in case you do need to jump off. McKinstry will be represented at our upcoming Higher Education Climate Leadership Summit, which is going to be in Atlanta, Georgia in late February, in actually exactly, 6 months from now. And you'll be able to meet them and other experts at that event, and we hope that some of you will attend there. And since this is the week of the solstice, I want to wish everybody the best for the upcoming season. There were a couple of questions that were submitted through the control panel. One of them related to the operation of the building and the long-term use of the building. So I was wondering if Brad, you could comment on how does this kind of a building impact the staffing of a building where historically you might have had a building engineer. Do you need more of that kind of expertise or less? And will this building still be around in 75 years from now? Or is there some longer term issues that with wood make it harder to maintain over the long term?
Yeah, it's a couple those are all really good questions. So I'll take the wood question first. I believe the construction durability of this building is going to be completely on par with a steel and cement building. It has more to do with how weatherproof the structure is. The cathedrals of Europe are wooden if you go behind the walls, and they've been standing for 700-800 years, and this is frankly structurally a lot better than those buildings. Regarding the operations, in this case, this building will continue to be operated by McKinstry. One benefit of the district system is it actually means that at the individual building level, you don't have as much to take care of. But I think that the broad takeaway I want to leave with folks is what I had said earlier. I believe these do not become boutique buildings that other folks can't operate. We're talking about technologies that actually are fairly well understood. It's zero energy to me typically is taking all of the great technologies that are understood and put them in one building.
Can you say a little more about the district energy plant that's being built there? Is this like a hot water system for heating or water system for cooling? Is it electric operated, natural gas, or how is that powered?
Yeah, one of the things that we really believe strongly in is that we believe the future does not include combustion and fossil fuels, and so it is an all-electric district energy system. It's quite innovative that way because most district systems do use gas. So we went and stretched and figured out a way to do this with all electricity. It's provided, so essentially what it's doing is it's providing all of the heating and all the cooling for 5 buildings. So what's created is basically a pot of hot water and a pot of cold water, and those are then circulated to the buildings, and then those are then circulated through the buildings hydronically in the building, and there's different distribution systems in the different buildings. Yeah, and I should add that the Living Future Institute, we knew we wanted to certify through them. They actually do not allow combustion with some limited exceptions. So, but for main things like heating and cooling, they don't allow combustion, and we supported that and wanted to comply with that.
Okay. You're a national firm. Can you say a little bit about the different energy costs versus in the East Coast versus West Coast or Midwest? Are there significant differences there?
Boy, good question. The math is different everywhere. It's remarkable. And so I'm not even going to try to make generalities. The East Coast does have very high electrical costs. California has high electrical costs. You have very low electrical costs in Colorado and in the Midwest. So it's all over the place, but it really reinforces that when you're looking at your specific campus, you have to do the math. And sometimes things are counterintuitive too, which is kind of interesting. If gas is cheap, it tends to favor, people. What I see in some places is people raise the price of electricity, even though they want people to move to electricity, but gas stays low. And so they haven't worked out the utility pricing to really push people away from gas in many cases.
Can you say something about the thermal energy storage system in the building? There was a little slice there on one of your figures showing thermal energy storage.
Yeah, I'm glad folks noticed that. That's actually, I had to jump over that. That's a very innovative part of the project. So what we will be doing is actually, we have, one of the development partners on Catalyst is Avista Utilities, and we have worked out a pricing structure with them where we have time of use pricing, and actually they have the ability to kind of intervene in our system, and they can actually, when they have excess production or excess electrons on their system, they will actually do thermal storage in the district plant. So let's say it's during the summer, they have kind of excess capacity, often midday you will have that. And so they'll make ice at those times, or maybe at night, and then the project will draw from that and use that ice during the times that the electricity is in most demand. And so it's a grid beneficial relationship. And that's very much a frontier-y kind of thing of zero energy right now.
Okay, so the energy storage is actually related to heating and cooling of water.
That's right.
And
it's thermal
sometimes
storage.
phase change.
It is phase change, yeah, and it's just simple phase change. It's ice, but that is a phase change, yeah.
Okay, I'm looking at the online questions here. Can you please explain the impact of density on energy efficiency? So the large buildings, high-rise buildings, you did sort of allude to the fact that in the larger buildings, you might have energy production at off-site solar arrays, or again, theoretically also off-site windmills, correct?
Yeah, so, I mean, a couple of things. It is, one thing is energy density is really an interesting conundrum in that, if you increase the density of a building, say with just occupants, that's a more efficient thing to do. You're 50 people in 10,000 square feet versus 20. It's just you're capturing more benefit, but the reality is it's going to make you look worse because you're using more energy, and that's frankly, our energy metrics are a little rough that way right now, and I think that's an area that needs increasing focus. I think one of the beauties of folks starting to move into a more benchmark-driven approach is they can take that into account and say, we're not going to just automatically say, okay, an efficient building has an energy use intensity of 20. It's more like, well, it depends. Let's look at your energy density and your occupant density and those sorts of things.
Okay, I now have a question for Dean Bowman, where you talked a little bit about the interactions you had with the stakeholders that are below you, like the department chairs and the faculty and the adjunct faculty, and their role in the decision making. Can you say a little bit about your relationship in the role of people who are perhaps above you in the decision making pyramid? So
Sure.
the president, the chief financial officer, perhaps the trustees, how did they get involved in this process?
Yeah, that's a great question. From the very outset, in fact, I think the entire concept from the building actually came through some meetings that our president had with Dean Allen, the principal for McKinstry, as well as the principals for Vista Utilities. And that's really in a lot of ways where the concept came from. And then the discussion was what makes the most sense for the university. So that really goes to Brad's point about, thinking about this in your larger context of what you want to do as a campus towards energy efficiency. And so it really was a collaborative venture for us, from the president to the board of trustees, all the way down to the adjunct faculty who teaches one class a year. Everybody was engaged in it in some sense or another. And it is part of a larger puzzle for us. I alluded to it briefly, that we're building a new science building that we intend to be LEED Silver at least when it's completed. That's a big deal. That's how you get your campus towards that sort of zero energy goal that we aim for. So in terms of talking farther up the food chain, this is part of a bigger mosaic for us, and I think that's what makes it exciting and successful.
Can you go even farther up the chain in terms of, say, the mayor or the governor or leaders in various state agencies, and not just what's happening within your public universities?
Right. Yeah, that's yes, absolutely. In fact, the city of Spokane, is as a city and as the leader in the region, has always had a strong emphasis on sustainable energy. The city exists because of hydropower. And so that's a big part of what Spokane's goals as a city is. Last year, I actually joined a team led by the mayor of Spokane and several county and regional business leaders and political leaders to go to Copenhagen and spend a few weeks in Copenhagen and through Denmark looking at some of the facilities they do there. District heating and district support, the way we're building in the Catalyst region, is something that they do in Europe. Not quite in the same way that McKinstry is doing this time with the no fossil fuels at all. That's a really cool innovation. There they do district heating that still at its core has the burning of fossil fuels. So yes, absolutely. Our regional political leaders are very engaged in this and hope to see this as a way to spur what's happening across all of Eastern Washington. And certainly in the state of Washington, our governor is very involved in supporting green initiatives like this. It's sort of a central part of what his tenure as governor and other things has been focused around. And it helps us for sure in dealing with the legislature. As a state institution, we do serve the state of Washington and the people of the state of Washington, and we are need to communicate very closely with our legislature in Olympia to do anything that we want to do for growth of the campus, and it's all centered around efficiency for these kinds of things and the public partnerships that it represents.
Okay, thank you so very much. I am aware that it's a few minutes after the hour, and I would like to thank everybody for participating in today's program. It was recorded and it will be available to your friends and colleagues if they'd like to look at it. The contact information for David and Brad is there, so if you'd like to reach out to them or me for additional feedback, please let us know. Anybody who would like to go to Denmark to learn more about district energy systems, the Danish government has a study tour every fall, and I'd be glad to share information about their study program. I think it's a 4-day trip starting in Copenhagen, and they travel around to look at various district energy systems that the Dutch government and the Dutch business community have installed. So thank you very much. I appreciate your time, and I hope to see some of you in February in Atlanta. And our next webinar is on October 17, focusing on procurement of electricity and all of the different acronyms that relate to the purchase of electricity. Thanks so much, and bye-bye.
Thanks, bye.